Hey, welcome back to your favorite pre-calculus class. We're going to look at the graphs of rational functions. We'll continue analyzing those and their graphs with all the asymptotes and slant asymptotes, etc. So here's the first one, y equals x minus 1 over x squared minus 4. So we're going to take a look, first of all, we're going to take a look at your vertical asymptotes. So let's make sure that we have this thing factored out first. So top's already in a linear factor the bottom here. So our vertical asymptotes, notice nothing cancels. So x minus 2 equals 0. Looks like we've got one at x equals 2. The other one, if we subtract 2 on both sides, we've got one at negative 2. So x equals 2 and x equals negative 2 are our vertical asymptotes. So we'll never touch those lines. Our horizontal asymptotes, if you look at this thing in standard form, the degree of the top is 1. So that's our n. Degree of the bottom is 2. So 1 is less than 2, that's our n and our m. So if you remember from last time, it's automatically y equals 0 because if you plug in large values of x, it'll automatically go to 0. The bottom will be so much larger than the top. So we have y equals 0 on this thing. It'll never, or I should say it may cross, but at the extremities with a horizontal asymptote, you're going to approach that y value of 0. And then at this point, you can say, well, is there any values, or are there any intercepts? You know, do you have any x or y intercepts? If you allow x to be 0, you know, you got 0 here and 0 squared minus 4, we got 1 4. So it does cross at 0, 4. That's one of our points. 0, 1 4 of the way up. If you allow 0 to be your y, what makes this true? So you just got to get a 0 on the top. So, you know, where does x minus 1 equal 0? Well, when x is 1. So you got the point 1, 0. It'll hit right there. Come on. There we go. 1, 0. And then we're just plugging in a bunch of points other than that in between our asymptotes. So we have 1, 0, 0, 4. Let's plug in negative 1. Throw in negative 1. I get negative 1 minus 1 on the top. Negative 2 over negative 3. So 2/3. I got negative 1 up 2/3 of the way up. Maybe you want to plug in like negative 1.5. You're going to see that's a little bit higher up here. I don't want to take too much time on this. We're going to do a bunch of examples today. But you want to throw in like 3 as well. So you got 2/5. Throw 3 in. You got 2/5. Anyways, we throw in a bunch. I've got the graph right here. So 3, 2/5. There's your 3, 0.4. You got your other points on there. You see your vertical asymptote, x equals 2, x equals negative 2, and y equals 0. Okay, plug in a bunch of points in. Let's do some more here. If we go ahead and factor this one again, we got x minus 2, x plus 2, all over x. There's nothing that cancels out, so you're going to have a vertical asymptote for that denominator, x equals 0. Your horizontal asymptote, you're going to look at the degree of the top is 2, degree of the bottom 1. Whenever the degree of the top is greater than the bottom, so 2 is greater than 1, there's no horizontal asymptote. Now it's only one bigger. So we want to go ahead and do the division because we're going to have an oblique or slant asymptote here. Okay, so we do the division. X squared minus 4 divided by x. What times x gives you x squared? You say, well, x does. X times x, x squared. X times 0, 0x. Forget to change your signs. It's both gone. Bring down the negative 4. There's your remainder. So this can be written as y equals quotient plus remainder over divisor. Negative 4 over x. This right here is your slant asymptote, the quotient there. So y equals x. Okay, so from this point now, we've got x equals 0, vertical asymptote. We got y equals x. So we've got X equals 0 is our vertical asymptote. It's never going to touch this. X equals 0, our y-axis in this case. And then we've got y equals x as our slant asymptote. And then from this point, we just want to plug in a bunch of points into the equation x squared minus 4 over x. So plug some points in. Maybe throw in 1. You got 1 squared minus 4, negative 3 over 1. 2, you got 0 over 2, which is 0. So 1, negative 3, 2, comma 0, 3, you got 5/3. So 3, we're up 1 2/3 of the way. Anyways, we could keep doing some more, but I know as I'm approaching 0 from the right, it's going to shoot it down because I have this vertical asymptote. And as I keep going out further and further, like 4, I got 12 over 4, 3, 4, comma 3. As I go out further, because this is a slant asymptote, I'm going to get closer and closer and closer to that dotted line, that slant or oblique asymptote. I could keep plotting some points there, but we could throw in some other points like negative 1, and we've got negative 3 on top over negative 1, which is 3, so negative 1, 3, negative 2, we got 0, negative 3, we got 5 on the top over negative 3, so negative 5/3, negative 3, I'm down 1 2/3 of the way. Anyways, we keep going with this. That's what you're going to kind of see, is because we're going to be approaching slant asymptote here, and over here it's going to shoot us up because of our vertical asymptote. Okay, here's a little better picture of that with some points. And again, you see that slant or oblique asymptote. You see the vertical asymptote. As I get closer to the vertical asymptote, it's shooting me up. As I get closer to the vertical asymptote, it's shooting me up. As I approach, as I go x goes to infinity, I'm getting closer to that slant asymptote there. Okay. Alright, here's another one. Y equals x fourth plus 1 over x squared. This thing's in factored already, so you've got your vertical asymptote, or I guess you can think about this as x times x on the bottom. At x equals 0, x equals 0. So it's the same vertical asymptote there. Notice the degree of the top's 4, degree of the bottom's 2. When the degree of the top's greater than the bottom, there's no horizontal asymptote. So what this is going to have, since it's 2 more than the bottom, 4 over 2, it's going to behave like the power function. You've got the 1 over the 1 there. So 1x, and then you take the degrees, 4 minus 2. So it's going to behave similar to y equals x squared at the extremities. Okay, I'm not going to walk through this whole thing because now it's just point plotting from here, but here's a nice picture of that. Oops. If you plotted some points, and notice we have our x equals 0, we've got our power function x squared that's approaching, plot some points like 1, 2, get some other points, get a bunch of points, points, and you can see this function as we go out gets closer to x squared, and as it approaches 0 from the right, it's shooting us up because we got this vertical asymptote. Same thing over here on the left. As I approach 0 from the left, it's shooting us up, and as I decrease in magnitude here, if you will, it's getting closer and closer and closer to that power function y equals x squared. Okay, here's another one, 3x squared minus 3x. Let's go ahead and put this in factored form. So we got 3x, x minus 1. On the bottom we've got x plus 4, x minus 3. So we'll start with our vertical asymptotes, and notice nothing cancels there, no factors that cancel. So we got negative 4, and we've got 3, x equals negative 4 and x equals 3. Our horizontal asymptotes, if we go back to the standard form, degree of the top is 2, degree of the bottom is 2. If n equals n, if the degree of the top and the bottom are the same, then I take my leading coefficient, so y equals 3 over 1. Y equals 3. So we've got negative 4, we've got 3, x equals 3, and then we've got y equals 3 for the horizontal asymptote. And now we're going to plot some points. We're just going to plug values in for x. Okay. Blow this up a little bit. Oops. you can see here's our x, y equals 3, here's our x equals 3, here's our x equals -4. Now it's a matter of plotting some points. Plot points, plot points, plot points, plot points, plot points, until you see the function. Okay, plug them in for x, spit your y out. Alright, how about this one here? We've got 2x squared minus 5x plus 2 divided by x squared minus 4. If you notice here, when you factor this thing, let's see, that'd be 2x and x, and you're going to have minus 1. Would that be minus 2? Does that work? 2 squared minus 4? Yeah, that works. All over x minus 2, x plus 2. So we factor it so we can take a look at our vertical asymptotes. But notice, this thing's not in the lowest terms. So because those cancel, I mentioned this at the end of the last section, because those cancel, what you have is a hole, not a vertical asymptote. We still know x cannot be 2. Like, it's not in our domain, right? Because that makes it 0 on the bottom. We cannot divide by 0. But we have a hole, because what you want to think about here is you can't just cancel these, okay? We're simplifying this function into this function, which is a different function. But this function behaves exactly like this function, the simplified version, except the original has a hole in it. Where at x equals 2, right? At x equals 2. But they look exactly the same, okay? They both have a vertical asymptote because of that right there at -2. So x equals -2. Alright. As for the horizontal asymptote, go back to the standard form, degree of the top, same as the bottom. So when they're the same, take the leading coefficients, 2 over 1. So y equals 2. Okay, so what we have here is a hole at x equals 2. I don't know where the hole is right now, so I'm going to leave that alone for just a second. I have the vertical asymptote x equals -2. I have a horizontal asymptote at y equals 2. Now, where is the hole? So what you do is you plug it into the simplified different function, and you can find out where the hole is. So this hole, when x is 2, is I plug the 2 in here. So 2 times 2, 4, 4 minus 1, 3 on the top, over 2 plus 2 on the bottom, 4. So at 2, and I'm 3/4 of the way up. That's where my hole is, right there. Okay, and then I could just plug in other points, like plug 1 in. I got 2 times 1, 2 minus 1, 1 over 3, 1/3, 1 comma 1/3. Oops, 1 comma 1/3. Why isn't it doing it? 0, -1/2. Anyways, I plug in some points. I get a look at it. Plug in some points over here, -3, and I've got what, -7 over -1, 7, -3 comma 7. Anyways, you can plot it. Let's take a look at the nice looking graph here. There's our -3, 7, it looks like, but notice the hole right there. So how do you find the hole? You plug it into the simplified version of the function. So because it behaves exactly like it, even though it's a different function, but it'll tell you where the hole is. Okay. So, alright, well, I appreciate you guys sticking with me today. We'll see you in class.